Hopefully everybody found good restaurants, good place for dinner. Sorry about the heat today. We haven't had this kind of heat all summer long. I don't know why I decided to come in today. We are fortunate today to have Mike Clark, who's with a company called Rogers O'Brien down in Dallas. Mike had his background before Rogers O'Brien with Hensel Phelps. He's the director of field engineering, which is actually kind of interesting. He reports up to a group, even though he's over the jobs, reports up to director of innovation. So he's bringing a lot of the tech to the field. And he's got an excellent presentation for us today on the use of drones and analytics on the job site. So, Mike, it's all yours. Thank you.
Thank you. Morning, everyone.
Morning.
And I'll apologize right now for bringing the heat that came with me from Texas. I didn't mean to. I was really wanting it to stay down there and enjoy the 70-degree weather that we were having, or that y'all are having up here. I am honestly a little tired of our 110-degree weather. Yeah. All right. So, sometimes the whole is greater than the sum of its parts. Now, this quote perfectly captures the essence of what I want to talk about today. Again, I'm Michael Clark. I lead our field engineering department at Rogers O'Brien, and one of my biggest passions is trying to innovate the survey and layout process. So, I'm absolutely thrilled to be up here and speak to all of you and showcase how, through innovative thinking, we can create exciting new workflows and maximize the power of our current technology. I'm going to share with you one of our more recent success stories that actually had an article published by Autodesk earlier this year. This is a K-12 project that we're doing down in Austin, Texas. It's pretty much comprised of several standalone buildings that are connected by sidewalks and pavement. You know, typical school building here. Now, initially, everything on this site was installed per the contract documents, worked as designed, turned over the building with no problems. However, about 5 years after turnover, they came across some unforeseen challenges. Most of that was due to soil movement. It caused a lot of drainage issues to the point where water was actually flowing back into the building. So, this is, like I said, a very common issue down in Texas, and it really reminded me of a project I was on about 7 years ago out in Fort Worth. Very similar issues, very similar problems. But back then, we didn't have the technology that we do today. We didn't have drones and all that fun stuff. We had to do a traditional survey method, which means sending a crew out to the job site to manually collect all of that data. Now, I'm telling you, that was a chore. It was extremely time-consuming, labor-intensive, and because of that, we really, realistically, only captured points about every 10 to 15 feet, just so that we weren't out there for days and days and days on end. All right? And then, after that, we still had to bring in those hundreds of points that we would collect and process them through Civil 3D to create a design surface, which is pretty much, if y'all don't know, it's a 3D representation of the surface elevations that we collect. Well, the problem with that is the fact that since our points, our data collection methods are so spread out, it can lead to some incomplete data sets and cause so much headaches. Even after all of that work, which realistically takes about a week, a crew an entire week on site doing data collection and processing that information, we would still have to go through and visually interpret that model by going through and scanning all of our contour lines and trying to mainly figure out, okay, where's this chop hole in water? You know, it's like, well, I think it's a little bit here, think it's a little bit here, but really no way to accurately figure that out. So A year ago, we were approached by the school about the issues that they were having. I mean, I'll be honest, I was like, man, this is gonna be a headache. This is just gonna be, I was dreading it, to be honest with you. But while we weren't contractually obligated to help them, we turned everything over, none of it was on our end. We do have a commitment as being the premier builder of Texas that that really drove us to want to help them out and find a solution for them. This was actually an active school at the time. I mean, students there 5 days a week. I think it was 7:30 to 4:30 in the afternoon. So we had a lot of, I think you'd call it time sensitivity on how we could capture this data. That's when I was officially brought in to assist with this. And we started thinking of, how can we do this survey without spending a week on site, but we also don't want to compromise the quality of our surveys. We don't want to speed up the process and come out with something that's just unusable, that doesn't do anybody any good. So, enter propeller air. This is a new groundbreaking drone technology that we've just begun piloting. No pun intended. But this technology, while it's primarily designed for doing dirt surveys by stitching together aerial photographs into highly accurate 3D models. I mean, when I say highly accurate, I'm talking sub-inch at a 200-foot elevation. So think about that. What this means is that with just a 20 to 30 minute drone flight, depending on the size of your site, you can create a 3D model and accurately calculate how much soil is being removed from your project between surveys. How much more soil you need to bring on or take off to get your entire site to grade. And what we found really cool, you can actually verify and document that all of your dirt work is to grade and match contract documents. Now, another added value that we came across with this one was the fact that we can process all of this information to our local coordinate system. This allows us to easily input and overlay all of our CAD files into the program. That way we can verify anything from, piers, underground utilities, slab edge. We've even started using this program for verifying sleeves and concrete slabs and documenting our PT cables before we pour. And since everything is on our local coordinate system, it easily transfers back to the field so that we can go lay out or just anything. But there's always going to be a but. We didn't have a way to easily analyze all the data that this captured and processed into something that would be usable for the design team on this project. I was racking my brain on that one until I finally sat down with our director of VDC, Chris Patton, who's also a fellow leader in our innovation group with me. We sat down, we collaborated on possible solutions for this, and that's when he introduced info drainage. It's a relatively new product in the Autodesk library. Now, this was originally created for designing civil drainage systems by allowing the user to take a civil surface, surface design, and with just a click of a button, add in anything from storm pipe, manholes, area drains, inlets, even water retention systems, and then run it through a simulated rain event, which they call deluge, and verify that it would work as they designed it. Also that it would meet local codes and specifications. Now, it was deluge that really caught my attention. and maybe think of it as a possible solution for analyzing all this data that we're collecting. Now, I'm going to step back a little bit and say, throughout this whole process of research and discovery, I often thought back to a problem-solving technique that I've used many times throughout my career. And it's very simple. It just goes, I wonder, what if, and let's try it. First off, we were brought in and forced to wonder, is there a better way to do these surveys? Because everybody knows innovation is just all about finding a better way. Now that we've done the research, we're like, whoa, what if we combine the accurate data capture capabilities of Propeller Arrow, and then we combine it with InfoDrainer's ability to easily analyze that data and produce something usable. Now, all we have to do is try it out. I'm going to tell you right now, our results were nothing short of fantastic. In just 1 hour on site, we established our site control and captured everything we needed with the drone. I'm not talking about points every 5 to 10 feet. Every single thing on this site, we were able to collect and process. From buildings, sidewalks, inlets, retention ponds down there, everything. And then Propeller processed that into a service model for us. Then it was just an easy process of taking that service model, putting the Civil 3D, and letting the InfoDrainage Civil 3D plugin kind of do its thing. Within just a few minutes, we were able to run deluge and accurately calculate where our problem areas were. It showed us exactly where we would hold water on site, how much water was actually being held in those areas during a rain event, and most importantly, it showed us how water flowed across the entire site. Now, this was pivotal because this helped us to ensure that by fixing one problem area, we wouldn't adversely affect anything else on the job site. Cause us to chase issues all around the job site, fixing one area, messing up another one. It helped solve all that problem. But the value didn't really stop at that. With the interoperability of Propeller Arrow and InfoDrainage, with their shared ability to import and export DXF files and XML files, which is basically just line work and elevations, we were able to seamlessly transmit all of the data from InfoDrainage, all of that data, and put it right back into Propeller Arrow. This combined with real-time data analytics from InfoDrainage with the highly accurate models to do a really nice overlay. Powerful visualization tool when you start sending that to owners and everybody on problem areas and where they're going to have issues with their drone. Now, one cool thing about Propeller Arrow is that it has unlimited sharing capabilities. That means that anyone who needs this information, got it, like that. Hit that little button share, put in their email address, no added cost, no setting up, usernames and all kinds of fun stuff. Just share, enter an email address, send it out, they can access this platform right here. Now imagine that. Everyone that needs the information gets the information. No unnecessary coordination meetings, you got it. Now, in conclusion, this workflow truly epitomizes the profound impact of innovative thinking by expressing the power of innovation, resourcefulness, but above all else, collaboration. Very important. Now, I want you guys to think about this quote when y'all return back to your companies. Because I want to activate and empower each of you to utilize this way of thinking to try to create new workflows for existing problems. Something else. This way of thinking doesn't just apply to how we utilize technology, but us personally and how we interact with people within our companies. We're all professionals here. And if we can collaborate with others within our companies, we will really achieve outcomes greater than the sum of our individual contributions, effectively changing how we do construction forever. I'm going to leave you guys one final quote from my mentor, our Chief Innovative Officer. He says it at every single one of our meetings, and I think it really relates to this process. If you want to go quick, go alone. But if you want to go far, you must go together. Now, here's a QR code if you'd like to scan it to read more about the case study published by Autodesk. They published it back in March. It's a very interesting little case study. It's about 5-10 minute read. Eric Suez did a very good job. And then here are the links to the two programs that we talked about, inflow drainage and propeller barrel.
Do you have time for questions?
Yeah. All right. Well, let's go build the future together, guys. Thank you very much for having me. Any questions?
Yeah, I was going to ask you, you had the school in place already, and then you flew over. So how did you capture in-ground detail with the school? Because it looked like you identified pooling under the school.
It wasn't under the school. It was pooling around the school, so we can run with our drone program. We can do what we call a 3D survey. So it flies at multiple angles. So it's able to capture everything right up to the edge of the buildings. And then part of their processing software is we can go in and I guess effectively flatten the school buildings so they don't interfere, so you don't have these huge gaps, these huge jumps in your surface designs. So it can go in there and say, okay, well, that's a building, that's a building, that's a building. Flattens it down to the ground elevation. Makes it reading it a whole lot easier.
Was there any more than measurement? Was there any LiDAR or other technology used to determine like temperature gradations where water might have existed?
Solely photogrammetry.
Okay.
Shows you that, photogrammetry has really come a long way in the past 3 years. I mean, I'm not going to say it's better or anything than LiDAR, but for ease of use and fast processing, if you're not needing to capture anything under heavy canopies or tree cover, photogrammetry is really going to get you what you need there. I mean, without any expensive sensors or the P1 sensor or anything like that cost a ton of money. Yeah, it's like 20 grand. This was a Phantom 4 RTK, with a 4K camera on it. I think the whole drone camera setup was about $5 grand. So, I mean, all depending on your use cases, but yeah, if we're not needing to capture anything underneath the canopy, we'll go photogrammetry all day long. Yes?
So, awesome. I love to see that, especially the connection of just not seeing the 3D, but how you tie it out. I think that's very, very powerful. 2 questions. So, why did you choose propeller aero, and how many of their propeller aero points you put out there, or perhaps you also did ground?
Okay, So, good question. So, we chose propeller arrow mainly for two reasons. The first one being their accuracy. So, they're one of the few drone processing programs out there that can get us sub-inch accuracy at 2 inches. I mean, most of our projects that we're doing with this now, we fly at 280 feet, and our residuals are 1/4 inch on the horizontal and 1/2 inch on the vertical. To go along with that, also the other reason why we went propeller arrow was the ability to import DXF line work. They're one of the few out there that can directly import everything in there because of the fact that they use custom coordinate systems. So whatever coordinate system I set up our project on, saying this is where it is in the world, that's what we rotate all of our CAD work to. It's not a known system. We don't do NAT 83 or anything like that, or state planes. It's our custom coordinate system that's given to us from actually the civil engineer. Because we discovered that most civil engineers don't use 100% state plane coordinates. It's close, like 5 feet, but 5 feet ain't gonna cut it. So now everything matches, everything's on the same coordinate system, everything overlays. That's the reason why we use it. Now, as far as ground control points, the reason why we get those accuracies is because we use a minimum of 3 ground control points, 3 arrow points.
3 arrow points.
3 arrow points, so we use arrow points. We use a minimum of 3 arrow points on projects. I think this one we actually used 5. So we try to do kind of a perimeter, get the full blanket and then do 2 to 3 in the middle. So that's how you can get those high accuracy data sets.
And they charge more for every arrow point, right? I think it's an additional cost to have more arrow points.
So they actually only charge you per the air, like it's $600 an arrow point. But the actual processing of it is just a straight fee. Yes.
So, y'all do all the drone flights like internally in-house, and
Yes.
do y'all did y'all work with any waterproofing consultants or anything like that, or did y'all just do it all internally?
So we do it all internally as far as drone flying. We do have an in-house quality manager who specializes in waterproofing. But then we're able to send all this data back to the civil engineer that the school hired, and all the surface models, all the fixes, because that was one of the big issues that they were having that we were trying to come up with fix for. They honestly didn't know where the water was collecting. I mean, unless it's just a big rainstorm and you go out there right after it happens, you're not going to know where it's ponding. You can see where it's coming in the building, yeah, but where are the other issues? So that's how we kind of came up with this solution. Yeah, we do all of our drone flights in-house. We probably have, I'd say 20 to 30 pilots for Roger O'Brien, just many drones, but we also kind of separate it out. So we have what we call, progress photo drones that are operated by the project teams. Then we have survey drones, for what I'm trying to coin as reality survey. It's using reality capture techniques to perform actual survey grade data. And we have currently 4 of those drones and 6 pilots that operate.
For the Phantom Force.
2 Phantom 4s, 2 Magic 3 Enterprises. Do you have a question, sir?
Yeah, so do y'all solely use this product or this type of engineering there, or do y'all still go back to the old school way of doing things to verify and quality check stuff? Because I think everyone understands in the computer programming world, things might not be 100% accurate. I personally would be concerned about relying on, it's what you put in is what you get out. So I'm just curious if you guys do a quality check and do certain points manually still.
Yes, so it goes back to the old reality capture adage of shit in, shit out. There's no easy way of saying that. The better the data you put in, the better data you're going to get out. But yes, we still go back, and when we're doing these surveys, we'll go back and as-build 3-4 points around the job site and store that data and put it into Propeller Arrow after it's done processing. So that way we can validate and verify, because there's always those, superintendents or project staff or owners like, well, I don't trust that. That was all done by a computer. The computers aren't as accurate as a person. Okay, sure, yeah, because, computers have tons and tons of error, unlike a person.
Now they're really reliable.
Yeah. information on
If
every
there's
photo.
ever like a glitch in your software, you didn't realize when you captured, I was just curious, you guys two-part quality
Yes.
check.
But we don't have to do as much.
Yeah, you just.
Yeah, we do what we call spot checking.
Yeah.
We'll go spot check a few areas around the site, especially if there's a certain part of that project that we're trying to capture or trying to get a survey on. We'll go through and do some spot checking just for validity, just to say, well, this matches, so if this matches, 98% sure everything else is gonna match. Oh, sorry.
This is great. You touched on the geo-registration issue with drone data, but oftentimes we see that problem on the design side. It's refreshing that you do not have that issue. We worked on thousands of data sets like this, and oftentimes, 99%, the design files that we receive, they're in some arbitrary coordinate system.
Yep.
Regardless of whatever we put into the project execution plan. How do you guys address that issue? Have you guys looked into that at
So
company level?
we take every single design file, Revit model, CAD file, whatever you want, and we actually have what we call a geospatial technician, something that a position I helped create within Rogers O'Brien. And his sole purpose is coordinating all of our design models, design files, onto a single coordinate system and single unit system. Because yeah, you'll get stuff from Revit, because I don't know how many of y'all have ever worked with Revit. Revit and civil coordinates don't exactly mix. It causes a whole lot of errors, so anything done in Revit is always on like a 0-0 coordinate system, where we work on a 6 million, 7 million, coordinate system. So his sole purpose is to create shared coordinate systems within these different files, so that way when we go and compile this data, it's all just stacks right on top of one another.
Is that person on project specific or at a company level?
Whole company level.
Got it.
So the field, he works directly for me,
I see.
and our fielding department is set at the company level, not the project level. We've completely taken it out of operations, and it's its own separate department that operates at a company and regional level. So he answers to me, and he's pretty much, he's the linchpin. Everything goes through him before it goes out to the field. Because we were having that same exact issue of, man, how do you get all this stuff to match up? And, at first, we had people like, well, we'll just kind of like do a visual overlay. Yeah, that's kind of fun. Yeah, because that's not going to cause inaccuracies. Coordinate-based system and site control is the way to go. That's the only way to go. I'll go out and say it right now. Site control and coordinate systems is the only way to overlay data accurately.
How old is that deluge program?
Oh, so we used it earlier this year, and I don't know when they were actually developed. I know they were acquired by Autodesk the year prior, so I guess that was 2022 is when they were acquired by Autodesk.
What's interesting about that is, are you familiar with Esri?
A little bit, yeah.
So Esri has a product called ArcGIS, which does all the geospatial ground stuff, and they have flow. I mean, they've had flow software.
Yeah.
And getting Autodesk and Esri to work together was like this legendary problem. But they were promising that they were going to. But now that they bought this, they're like, skip that part. So it's kind of interesting how Autodesk is evolving into recognizing the importance of the ground.
Yeah, I mean, because we start talking stuff like Civil 3D.
Yeah.
When you start talking about stuff like Civil 3D and doing surface designs and all that fun stuff, they were really lacking on something that you didn't need a civil engineering degree to actually use. I've used Civil 3D a lot, and I don't know half of what it can do because it's just way over my head. Now, I think I had a 2-hour virtual training class with info drainage, and I was able to go use it. Yeah, I mean, it's literally, you say, okay, I want to register this area, hit deluge, you tell it, I want to have a 2-hour rain event at 3 inches an hour. Just say you hit the button, it does all the calculations, and bam, there you go. It gives you contour lines, shading, gives you a nice little legend of, okay, right here you're going to hold 6 inches of water. It gives you arrows that can tell you it's all going to flow over here.
So to follow along with that alignment and coordinates and Revit models, you guys have a surveyor on stuff, and I ask because I don't. So I work with my surveyor to align everything, also because I don't want the liability of, I don't stake by any chance.
Oh, yeah.
I don't do any staking, but I also want to work with those professionals that are either going to find and flag an issue that I can tell the design team, or maybe it works and I already have an online file.
So, yes, good question. So we do not have an actual professional licensed surveyor in-house. We do have our fielding department, which, same thing without the license, pretty much. They're all trained people on how to read this stuff. We've all got several years in the industry. But we do work with surveyors to establish primary site controls, and we try to work with the engineer on record to provide that. We found that is so much easier. Oh my gosh. When you can get the engineer on record for that project to come out there and establish site control, dude, it's liabilities off of us. No, well, I need this file. No, you have everything. It's your job. You designed it. Go do it. You know? And then we just come through and take their site control and run our calculations and all our layout. And it goes back to the whole thing of, as a GC, I don't care what anybody tells you. We have the ultimate risk. I mean, as a GC, we are the risk takers. That's what we're getting paid for. Whether it's a subcontractor doing the work or the layout, we're still taking risk, you know. Oh, the subcontractor, they're responsible for it, they mess up, they gotta pay for it. Yeah. Well, who's gonna go tell the owner we gotta push the schedule out of a month because our subcontractor screwed the pooch and, you know, we gotta rip out concrete. Still risk on us. And this way we can help mitigate the risk that's already gonna be on us no matter what to help out our subcontractors and keep them from messing up. Any other questions? All right.
Nice
I
job.
appreciate your attention, guys. Thank you very much.